Hello folks, welcome back to Merrill Math. I'm Mr. Merrill, and today we're going to be talking about simplifying compound fractions. Now these are problems that you typically see in an Algebra 2 course. Usually it's toward the beginning of a unit involving rational functions, or maybe in the middle of one of those units. But rational functions are one of those things that sort of comes around toward the end of an Algebra 2 curriculum and tends to terrify a lot of students. So when we're talking about rational functions, what these are basically just fractions. Ratios are fractions. So that's what we're talking about today, is just the fraction parts of those. So compound fractions, what those are just fractions within fractions. And a lot of the rules that we're going to use are very similar to the ones that we've encountered before when we've taken arithmetic and pre-algebra classes and things like that. So the good thing about these problems is there's really only two guiding principles that are informing what our decisions are, how we proceed with the problem. The first one is just to find a common denominator for the top and the bottom. So the numerator of the compound fraction and the denominator of the compound fraction. You want to find common denominators for both of those. They don't necessarily have to be the same as each other, but they are going to be common for the top and common for the bottom. The next piece, and this is a rule that you encountered, I would say probably in 5th grade or so, when you learn how to divide by fractions. So what you do is, when you divide by a fraction, what you're doing is you're turning it into a multiplication problem. So you take the inverse, or the reciprocal of the divisor, and then you multiply by that, because that's really what division is multiplication by an inverse. So let's take a look at an example here. Okay, so we've got x over y squared minus y over x squared, that quantity over 1 over y squared minus 1 over x squared. Now, the first step, our guiding principle, like I said, we want to find a common denominator for the top and bottom. So right now we have two denominators that are not common. This is a y squared, this is an x squared, so they're different. So what we need is something that is common. So what we're going to do is introduce this denominator to this fraction and this denominator to this fraction. So in a sense, what we're going to do is take this x squared times the top and bottom of this, and this y squared times the top and bottom of this. Now, because we're multiplying the top and bottom of each of these fractions by the same thing, in a sense what we're doing is multiplying it by 1. So we're not changing any of the values of these, we're just changing what it looks like. And that's something that's fairly common in mathematics, is we're just changing how things look, but not necessarily what they are. Okay, so let's do that. So the x squared is going to be multiplied here and here. So we've got x squared times x over x squared times y squared minus, and then this y squared is going to get multiplied here and here. So I've got y squared times y over, and I'm going to do this in the opposite order here. So this is going to be x squared times y squared, so we can see that these denominators are the same, even though I multiplied this in a different order. So the commutative property allows me to rearrange these just to make it suit my needs. On the bottom, the same thing is going to happen. So my common denominator is going to be x squared y squared. So the x squared needs to get multiplied over here. X squared times 1 is x squared over x squared y squared minus, now y squared has to get multiplied over here, so y squared over x squared y squared. One thing you'll notice is you tend to run out of room very quickly on these types of problems. So I'm going to do a little bit of cleaning up here by combining these. Now that they have the same denominators, it just so happens that they're the same as each other, and we'll kind of deal with that here in a little bit. So I'm going to do a little bit of cleaning up, so multiplying these things out and combining them over the same denominator. So this part becomes x to the third, because x squared times x is that, minus y to the third over x squared y squared. And this part gives me x squared minus y squared over x squared times y squared. So now we have this. So it's still a compound fraction, but it looks a little bit friendlier. So we've got some common denominator things going on. Now we have to do our second guiding principle. So once we've got our common denominators sorted, what we're going to want to do is flip the denominator over and then multiply the numerator and the inverse of the denominator, or the reciprocal of the denominator. So we're going to do that over here. So x cubed minus y cubed over x squared times y squared times, now this is going to get flipped over, so x squared times y squared over x squared minus y squared. It's really easy to get lost in these steps, so you want to be sure to keep track of what you're doing here. So this so the next step here, we can do some canceling. So we notice that this x squared here and this x squared here, one's in the numerator, one's in the denominator. I can cancel them because they're common factors in a sense. So this x squared and this x squared can cancel. Likewise here with the y squared and the y squared. So this here and this here can cancel. So now what we're left with is x cubed minus y cubed over x squared minus y squared. And it looks friendly enough like this, but as we'll notice, this is a difference of cubes and this is a difference of squares. So both of these factor. So the difference of cubes here, I'm going to see if I have enough room. This factors in a very particular way. So x cubed minus y cubed becomes x minus y times, what do we have here? X squared plus xy plus y squared. So the way that the difference of cubes factoring works is we have our first term and our second term. So this here is just the same sign here and here. And the next piece, so this factor here, I've got the first term squared, I have the product of these two terms, and then the last term squared. This sign is going to be the opposite of this one, and this one's always a plus. So sum of cubes also will factor, but it would be x plus y, so it's the same sign here, and then it's the opposite sign here, so this would be a minus, and then that would be a plus. So anyways, this factors to x minus y and x plus y. So likewise, we have a little bit more factoring we can do. So the x minus y terms, so this here on the bottom and this here on the top, this we can cancel and this we can cancel. So what we're left with is x squared plus xy plus y squared over x plus y. Now you can make the argument that this looks a little bit simpler than this, but there's math has kind of a specific definition of what we mean by simplifying something. When you simplify it, you're not just making it look pretty. What you're doing is you're making sure that the numerator and denominator have no factors in common. So there's a very specific definition for that. So yes, this is very simple looking, but these do have a common factor of x minus y, so we have to pull that out. So as this stands, it won't factor any further, so this is the simplified version. Okay, let me see if I have time for one more. I'm very organized today. Okay. All right, so guiding principles. We need a common denominator for the top and the bottom. Now, the good news is we don't really have much of a choice because there's a denominator here and here. So for the top, our common denominator is just going to be x plus 5 because that's what that already is. We can pick whatever we want, but we kind of want to pick something that will offer us little resistance. So what I'm going to do with this 2, now we can think of this 2 as 2 over 1, so it kind of is a fraction. We're going to multiply this and this by x plus 5. So 2 times x plus 5 and 1 times x plus 5. So let's do that now. So I've got 2 times this quantity over this quantity minus 13 over that quantity. And I'm going to do the same thing to the denominator. So 2 times x minus 3 over x minus 3 plus 3 over x minus 3. So these two parts just kind of came along for the ride. Okay, now notice that if I factor this back out, x minus 3 over x minus 3, that cancels. That's just equal to 2. So again, we've changed the way this looks, but we don't change what it's equal to. So we're good to go here. We can clean this top part up a little bit. There's some distributive property and some simplifying we can do. So this part is 2x plus 10, and we're going to subtract 13 from that. So we've got 2x. I'm going to do this in 2 steps just so I'm not losing everybody. So 2 times x is 2x, 2 times 5 is 10, minus 13 over x plus 5 over, I've got 2 times x minus 2 times 3 plus 3 over x minus 3. And we're going to do a little bit of simplifying here. So I've got 2x plus 10 minus 13. So 10 minus 13 is a negative 3. So 2x minus 3 over x plus 5. And 2x, what do I have here? Minus 3. Ooh, that looks nice. Over x minus 3. So what we're going to do is our second guiding principle. So we have common denominators for the top and the bottom. Now we're going to flip this bottom piece over. So this whole thing here, we're going to flip it over and then multiply it by the top. So 2x minus 3. Let me get this thing to move here. Okay, so we've got 2x minus 3 over x plus 5 times this quantity. So I'm going to flip that over, x minus 3 over 2x minus 3. And would you look at that, this and this are common factors. So this piece here will cancel, and this piece here will cancel, and I'm left with x minus 3 over x plus 5. And life is beautiful. So that is a little bit about simplifying compound fractions. They look a lot worse than they actually are. If you sort of experiment with these and remember a lot of the arithmetic rules that you had picked up in elementary school when dealing with fractions, adding and subtracting, and factoring, and common denominators, and all that fun stuff. If you remember a lot of those rules, those will help you out immensely when you're working through these problems. So if you have any questions, comments, points of clarification, be sure to leave those in the comments below. Otherwise, thanks for watching.